I've just got a few samples, specimens from coal in Kentucky, and this is just the most obvious one. This is just a nice chunk of good old Kentucky bituminous coal. This real shiny, very clean piece, this is anthracite. Anthracite has undergone far more metamorphic change than bituminous, and so it's more densely packed carbon, and it's very clean, and but it's hard. It's much harder than bituminous coal. This is interesting because it's called a coal ball, but during the peat stage, when the swamp is forming and the dead, rotting plant debris is there suspended in the swamp, there are times where calcium carbonate can seep in the groundwater and actually make a fossil of the peat. In some cases, in the coal, you can still see the impression of the bark from the ferns and the tree ferns in the swamp. You can still see that, the bark. This is lepidodendron bark on this one. During the time that the swamp was forming, volcanoes erupted close enough that an ash fall of volcanic ash fell into the swamp and is preserved. And what's really interesting about this is called a tonstein. It's a clay, a very hard clay. You can extract minerals from this that contain age-datable elements. So we've done argon age dating on this, and it comes out that this coal bed and this ash fall is 311 million years old. This is pretty cool. I mean, it's just, these are common as can be in eastern Kentucky, but this is just a piece of a limb of probably a tree fern, and you can still see the vein from the center of the plant, and you can see the bark layer is still on it. It's now turned to coal, but it's just part of this plant material that formed our coal. Here are some what are known as concretions, and these concretions beautifully illustrate the fern, the tree ferns and the ferns that were in the swamp, and these come from coal beds. People who actually study coal will make slabs, a lucite, like a polyurethane, and then cut and polish the piece and look at it. That's what the microscope is for, to look at the different layers and see what's in the coal. There's a very interesting technique called thin sectioning, where you take coal and you cut it into a very thin sheet. And when coal gets to be very, very thin, it's no longer this black that we know, but because it's made up of waxes and lignins and different chemicals, it becomes a beautiful yellow and red and other colors. And then we would take this and look at it under the microscope, and you can see just a whole lot of interesting features that still are preserved in the coal.